Viewers, welcome to Science Spectrum with Don. This is Maths 188, the fundamentals of mathematics. And of course, this would be the first part of the second lecture in variation. So, the first key question you may want to ask is, what is variation? What is variation? Now, there are quantities, okay, several quantities, okay, that actually exist. Now, the relation between two or more of these quantities, we call that variation. So variation is the relation between, or the relation that exists is the relation between two or more quantities. Now, there are times we could use the word variables. The word variable there simply implies that I could represent a quantity, okay, with a letter of the alphabet, say X, say Y, and if you like, okay, you could stick in a Z. And if I could replace different values for these letters, I could use the word, okay, variables. So the relation that exists between two or more quantities or variables, we call that variation, right? And that relation, okay, oftentimes is often denoted by this symbol. So this symbol stands for varies. This is varies. And of course, to replace this, I could stick in an equal to sign with a constant of proportionality. The moment I stick in this, okay, I have replaced this. So let's take an example. Let's say, for example, quantity X, okay, varies directly to quantity Y. This is direct variation. So I could simply replace this sign, this vary sign, with an equal to and a constant. Then I have an X here and I have a Y here. And of course, if I divide both sides by Y, right, this K, which we call the constant of proportionality, becomes the ratio of X to Y. That is if, okay, this is a direct variation. All right, and now let's quickly talk about briefly the types of variations. There are types of variations, so I will treat each of them, okay, extensively. So we talk about types, the types of variation, types of variations, all right? So the first one is direct variation. The first one is direct variation. The second is indirect or inverse variation. So I'll use the word inverse or indirect variation. The third one is joint variation, while the fourth is partial variation. So let's, okay, treat each of these types of variations now, okay, individually. Now, what is direct variation to start with? Direct variation is simply the relation between just two quantities. The relation between two quantities, okay, such that an increase or decrease in one of the quantities, okay, would result to a corresponding proportionate increase and decrease in the other quantity. So let's start with this direct variation. So direct variation, okay, is the relation between just two quantities, okay, such that, okay, an increase or decrease in one quantity, okay, would result to a corresponding proportionate a corresponding proportionate increase or decrease, okay, in the other quantity, right? So this is direct variation. So I give an example on this. Let's take, for instance, let's assume that the first quantity, okay, let's call that x, and let the second quantity, okay, let's call that y. So let's take, for example, the first quantity is x, and the second is y, okay? So if the relation between them is direct, it means I will stick in this, okay, sign. So what it simply implies is, I need to get some color codes now. What it simply implies is, if quantity x increases, okay, quantity y would also increase as well. And what this also implies is, if quantity x drops, reduces, quantity y, okay, would also reduce. So this is what we call direct variation. And I give you a real life situation. Let's take, for example, that I have, I compare, okay, let's say the number of tins of milk, okay, I denote that by a capital letter N, okay, this is one quantity, you could call this x, okay, and okay, the price or the cost, okay, of, okay, tins of milk, So I could give this a symbol, capital letter C. So you could call this quantity x, which is n in this case now, which represents the number of tins of milk, and the other could be, okay, the cost of the tins of milk. So now clearly, the more the number of tins of milk, right, the more the cost, right, increases. And the lesser or the fewer the number of tins of milk, right, the lower the cost of tins of milk. So I could write this as the number of tins of milk, okay, is directly proportional to the cost of the tins of milk. Now to replace this sign, this very sign, I would rewrite this as n, and I will replace this with an equals to, with a constant proportionality, and I have the other quantity, which is c. Now I could divide both sides by c, right? And my constant proportionality becomes the number of tins of milk over the cost of the tin of milk. Alright, so let's do a working example now. So let's take, for instance, that I have two quantities. Let's say I have quantity A and B. So let's say quantity A, example one. So let's say quantity A varies directly, okay, as the square of quantity B, right? So when quantity A is 35, okay, quantity B is 25, right? So the question is this, okay, if, or just say when quantity B, okay, is, let's say 14, okay, find quantity A. All right, so this is a direct variation question, and let's, okay, do justice to this briefly. So solution to this is, this is the relation between quantity A and B. So quantity A varies directly as the square root of B. So I could replace this sign with an equals to, with a constant proportionality K, then I could write the variables here, or the quantity here, B. Now to find K, I could divide both sides by the square root of B, divide this by the square root of B, and definitely we figure out that K, which is the constant of proportionality, is simply A, quantity A over the square root of quantity B. Now A is 35, and B is 25, so the square root of 25. So definitely the K, my constant, becomes 35 over, the square root of 25 is 5, right? Then when you divide out, you figure out that K is just a 7. Now from this, I could tell you what A is, okay, provided I know B. Why? Because the constant of proportionality, which is K, would not change. So let's proceed now. Let's proceed further. Alright, so let's proceed further. Now, so I'm interested in knowing what A is given the value of B, since I know that my constants of proportionality would not change, okay? It stays the same all through, as long as this relation exists. So to express this now mathematically, I will write A is proportional or directly proportional to the square root of B. I replace with an equals to sign and a constant K, which we know for now. And I have an A is equals to square root of B. Now I could write this mathematically, or the function, okay, that relates A to B, which is the formula, is simply A is equals to, my constant is 7, okay, times root B. That's it. Now from the second pair, the second statement, B is given to be 14. So A is equals to 7 times the square root of 14, right? So we are asked to find A. Just a quick one. So to get this done, the square root of 14, I need to punch this. The square root of 14, the square root of 14, okay, this translates to, let's say 3.7 to 1 decimal place. So A is 7 times 3.7, and 7 times 3.7, of course, I have 25.9. So A in this regard is 25.9. So this is the first example in direct variation. You may need to beam this for a while, okay, while we move on to the next question. All right, the second question, can I rub this off? The second question, that's example 2 in direct variation, would be, let's take for example that I have two quantities, let's say G and H. So let's say, example 2, quantity G varies directly as the square of H, for example, right? So let's now say G, okay, let me give this some values. Let me say G, let's say G is 4, okay, G is 4, when G is 4, okay, let's say H, okay, let's say H is 3, right? So the question is find H, okay, when G is 100, that's the question. So solution to this, just a quick one, solution is this. I could write this now mathematically as G varies directly as the square of H. I could replace this sign with an equals to and a constant K, then I'll stick in the quantities here, square, right? Now G is 4, and of course I don't know K, but H is 3, and of course it's raised to power 2. It's raised to power 2. So 4 is equals to 3 raised to power 2 is 9, so I have 9K. And of course, to find my constants, I could divide those sides by 9. So definitely, my constants becomes 4 over 9. Now, that 4 over 9 wouldn't change. The value stays the same. So from there, I could tell you what G is. Okay? I could tell you what H is, provided that I know what G represents. So let's proceed. Now, I could write this now, okay, as a formula to mean G is equal to, since I know K now, K is 4 over 9, then I have H squared. This is, okay, the mathematical way of writing the relation between G and H. Now, we're given G to be 100, so G is 100. I have the constant K, and of course I could tell you what H is from here, because I could write this as H over 1. So this becomes 100 over 1, 100 over 1 is equals to 4 times H squared is 4H squared over 9, right? And of course, 2 can go in 4, 2 in 4 is a 2, 2 in 100, okay, I have a 50, 2 in 2 is a 1, and 2 in 50 is 25. So I have 25 over 1 is just H squared over 9. Now I have two pairs of ratios on the right and on the left, so I could easily cross multiply. So H squared times 1 translates to H squared This translates to h squared. Write it down. This translates to h squared. And I have 25 times 9. 25 times 9. So to find h now, I could square root both sides. And once I do that, right, I lose the power half. So h becomes the square root of 25 times the square root of 9. And this is, the square root of 5 is 5, and the square root of 9 is 3. So h becomes 15. Alright, so this are just, few of the many examples we could do in direct variation. So for the sake of time, I may need to wrap it up here. You may want to like, share, and subscribe for more content. Thank you.